Okay, so today we've got a quick project that we're working on. This was based on an older project that I started a couple weeks ago called HackSnack. And what it is we're designing a PCB that can essentially hack a vending machine in order to make it accept Venmo. So in my lab, I'm trying to provide electronic components to my students and do so in a way that kind of makes it cheaper for them, because right now everything's super expensive on Amazon. So I'm bulk purchasing components straight from China, putting them into a vending machine, and then the idea is like they can buy them, but I understand that students don't really carry around just giant pockets full of quarters in order to buy $5 components. So instead, I'm hacking it in order to accept Venmo payments through a system that I have designed. But we got the PCBs back and there are some issues. And so I thought it would be interesting to kind of walk through some of the changes that we need to make in order to get this project back up and running. So we're going to start a new project called HackSnack v2. And I'm going to actually import the previous files. And so if I come up here and I open let's do this one. Yes. And let's open this one. Cool. So the way that it works is I have an ESP32 that's constantly checking a database that I've made that actually tracks my incoming Venmo payments. And if it sees an incoming payment, it actually triggers this relay that goes out to two wires in the vending machine that trick it into thinking that it's accepted a dollar bill. And then if someone sends $5, it just clicks it 5 times and charges it up with $5, and then they can make their selection and buy their component. The issues are that, one, we used the wrong GPIOs. I didn't check the GPIO pins before I designed this circuit, and very stupidly, I didn't use the same ones that we actually used in our breadboarded circuit. So when I got back, we found out that none of these actually work, and we can see over here on this this pinout reference that pins 6, 7, and 8 have big red X's next to them saying don't use those. So we're going to change that up. The other thing that I found that actually wasn't my fault is this relay diagram is not correct. And so when we got back the PCB, it turns out it had connected these 2 outer pins, which will never be connected, despite the fact that kind of we have it properly wired on this diagram. So we're going to make sure that that is wired correctly. And then we will send this off with our other PCBs this week to get batch processed. So let's go ahead and we're going to get these things saved. So save to an existing project, HackSnack. I'll just make sure that these both get in the right folder. Must be, oh, well, yeah, because I have to select the actual. Okay, and we'll save that there. Okay. All right, so first thing we're going to do is we're going to remove those connections. And let's see if we can find some good ones. So 13, 14, and 15 are all available. They're also kind of all over the place. Let's see. How about 16, 17, and 5? 5 is good. 16 and 17 is good. So I'm going to try to like not move these any further than I absolutely have to. And that's because that will have the least chance of screwing up my my circuit that I've already designed. So let me just double check. So 5 outputs PWM signal at boot. It's not a big deal. 16 and 17 are both perfectly fine, but 18, okay. So I might actually jump this one. I don't know what that PWM signal is going to do, so we'll do 16, 17, and 18. 16's okay, 17's okay, 18's okay. Cool. So let's just reconnect these. Good. And on this relay, yeah, we're just going to kind of play guess the connection. So I'm going to move this connection over here. And I should have caught this when I was designing the PCB. That's what happens when you kind of trust your schematic footprints a little bit too much. But so we live and we learn. All right, so let's update PCB. Let's keep going. And yeah, apply lots of changes. Replace bill, replace the, okay, yeah, that's fine. Okay, hopefully that just, yeah, did that. And just for simplicity, I'm going to remove my power and ground planes for the moment. I'll redraw those in just a moment. And let's go ahead and turn off ground and VCC, and let's look about what needs to get redone. Okay, so that one no longer exists. We see that it's now here. And that's one thing that I think I want to change, because I need to think about what's kind of normally open and normally closed. So I think I'm going to keep this one, but I think we're going to move this other connection over here. Again, assuming that this is how this relay actually works. So I want that one, and I also want to use this one, which I know looks really weird because on the schematic it looks incorrect. But I'm going to go ahead and save this. Okay, and then let's update PCB. Line changes. Okay. I'm just going to flip that around. And we're going to call this Dala. Ooh, let's get off that. Snap. There we go. Okay. Okay, so now we can see that kind of in the normally closed position, nothing will happen. Then, or sorry, in the normally open position, it won't do anything. If normally closed, it should trigger that dollar bill acceptor. All right, last bit is then we need to get all of these final traces made. And so we do have, let's go down to the original traces. Ooh, easy tiger. So those are no longer acceptable. And so let's go ahead and see if we can make some connections. I'm going to go to the bottom layer for this. Oh, interesting. Okay, maybe I won't go to the bottom layer for that. Or I will go to the bottom layer and just run this trace here. Don't like running the traces this close to the edge because it generally creates islands, but we should be okay. Okay, so let's save that up. Okay, so all I've got is my ground and VCCs remaining. Let's go and set snap to 5. And let's do a ground plane. And fill, and hopefully we don't have any horrible islands. Good. Okay, let's go to the top and let's do our power plane. And hopefully we will get lucky. And this will be in great shape by the time we're done. Yeah, okay. Just checking. And there we go. So let's just check our DRC. That's the design rules check. No errors. Good. And let's save that up. We'll double check our price. Cool, $4. That's what we're looking for. Okay, and that is HackSnack. The last thing we need to do is update this version so that we know not to use the old words. Font is missing. No, that's fine. So, we'll just go with the default. Not as cool as Roboto, but that's fine. Alright, so that's HackSnack v2. And let's go ahead and drop that height down. And that should be in great shape. Okay. Let's take a look at it. And that should be it. We'll get that sent off. Thanks for watching.